Let's find a second moment of area of this triangle about the centroid. To simplify this problem, we can use the parallel axis theorem to find a second moment of area about the x-axis, and then solve this equation to find a second moment of area about the centroid. And we know that the centroid is located at 1/3 of the height of the triangle. Now the second moment of area was the integral of y squared over the area of the triangle. And the differential area here is equal to x dy. And given this triangle has a height h and width b, then we can write the equation of this line as the slope, which is minus the rise over the run, by x plus the y-intercept. And we can solve this equation for x by subtracting h from both sides, and then multiplying through by negative b and dividing through by h. And that's equal to x. And therefore we can rewrite the second moment of area as an integral from 0 to the height of the triangle, and we have y squared dA, which is x or minus b on h by y minus h dy. And now we can simplify this integral by taking the constant outside. So we have the integral from 0 to h y cubed minus y squared h, and we integrate this over y. And now we can evaluate this integral. So we have minus b on h multiplied by y to the 4 on 4 minus y cubed h on 3, evaluated from 0 to h. So we end up with minus b on h by h to the 4 on 4 minus h to the 4 on 3. So that would be 3 on 12, and 1/3 is 4 on 12. So we get minus b on h multiplied by minus 1 on 12 by h to the 4. So therefore Ixx is bh cubed on 12. And now we can use the parallel axis theorem to solve for the second moment of area about the centroid. So we have bh cubed on 12 is equal to Ixx bar plus the area of the triangle, which is half the base by the height, multiplied by the squared distance between the centroid and the x-axis. So that will be h on 3 squared. And therefore we have Ixx bar is equal to bh cubed on 12 minus bh cubed on 2 multiplied by 9. And 1 on 12 is 3 on 36. And 1 on 18 is 2 on 36. And therefore Ixx bar is bh cubed on 36. Please subscribe, like and comment to help me reach more students.